I'm here with
Christensen.
And you're a guy that I've known now for, what, 8 years? The place, I won't say where, but the place, the client that I met you at, you're back at again, right?
It's true.
Yeah, small world. Just, I mean, think you're going to be someone, and hey, 10 years later, you're back here as a consultant.
Everything I learned was by the age of 25. I've just been regurgitating it again and again and again. In fact, I'm probably getting dumber. That's why I try to do these presentations once in a while. It's just like a holding effort to try and keep from becoming completely stupid.
Well, this is a totally sidetrack conversation, but along those lines, we were talking at work about, you can tell when you're working with a young developer because they code something and it breaks and they go, I found a bug in the compiler. Yeah. That's got to be Microsoft's fault, or Matt screwed something up in the Ruby runtime, or it's all somebody else's fault and it's not theirs. And you can see an older developer, when they screw something, they're like, they screw something up. They're like, all right, what did I do wrong? That's the first reaction. It's got to be something me. It's not.
And I've actually gone almost too far the other way, that anytime I'm working, and even no matter how horrible the code base is, I assume that if it's there, it's correct in some fashion. So even if it's a total nightmare, it's like, well, I did something dumb, I'm sure, because I always do.
It's a combination of being beat up too much and just also experience, the compiler is probably the most tested thing that ever comes out of, like, for example, .NET. That's like the one executable you run more than any other one probably out of there. So, all right, back into what you're going to be talking about tomorrow, which is Clojure.
Clojure.
Oh,
Clojure.
Clojure.
No, it's just Clojure.
Clojure, right.
The J makes it confusing, but it's just a play on words. Closures are a concept in functional programming, and it runs, it was primarily targeted at the JVM, so it's sort of Java-esque, and there is a lot of really nice syntactic sugar to make it really easy to call out to existing Java libraries from Clojure. What's interesting to me is I've been too kind of dumb and lazy to try the Clojure.net port of it, which is very active. Like the dude who works on the language, on the Clojure language, the guy who wrote it all, this guy named Rich Hickey.
Yeah.
If you look at the GitHub repo for Clojure.net, it's always updated within a day or two.
Yeah.
Any time you look at it. And I think it's one of those things where like only he cares about it. It's just some sort of like desire he has to make sure it's there. But I'd be interested to know if the same syntactic sugar that you use in Clojure to call into the Java stuff, if it's similar to call into the .NET classes if you're running on the .NET stack. I would hope that it would be.
Yeah.
I would think that it would be.
Should be.
Yeah. Because the mechanics of it would actually be pretty similar. I would think of all the things you have to sort of worry about for getting a functional language with macros to work on a particular runtime, and the differences between the JVM and CLR, or DLR, I guess you would say. That's got to be like a bigger problem than just worrying how you call out to classes. But I didn't build the thing, I'm just using it, so I don't have a strong opinion.
Go find Keith Dalby. He'd probably be a good one to ask about that, because he's all into he's done talks in the DLR and stuff like that. So he might be a good one to bounce an idea around for that one. He's actually here, so not here, but in the CodeCamp sense of the word here. So the specific thing you're talking about with Clojure, I'm going to get that right, Clojure, is macros.
Yeah.
Okay. So doing a whole talk on macros. What's so cool about macros and Clojure?
To me, it's not really about Clojure. Clojure is just a Lisp that I can use. I'm really into Lisp as a language in the family of Lisp languages, which just means really lots of parentheses.
Yes. But isn't that like one of the play on the acronyms is like lots
of insipid parentheses or something like that.
Lots of insipid, stupid parentheses or something.
Yeah, something like that. But there's a method to the madness of that syntax, or almost, I should say, rather total lack of syntax, which is that when you're writing programs in Lisp, the syntax or the form of the programs essentially is isomorphic to the abstract syntax tree of what a compiler would generate for any language when it first kind of does the initial parse.
Okay.
And what's powerful about that is that means that if you have a metaprogramming facility, or if you're trying to have a metaprogramming facility for generating code at compile time, or generating code in any way, you don't have to like learn a separate language or a separate way of doing that. Essentially, Lisp macro code, where macros are, you can think of them as special functions that run at compile time to generate code, which then gets evaluated at runtime. That doesn't somehow look different. It's not like a second-class citizen. When you're writing macros, you're writing Lisp code. It just so happens that your purpose of it is different than it normally is when you're defining a function. And when it gets evaluated, it's different. If I think of like read and parse, compile, runtime, it's at compile time. And that's what makes macros unique. And I would argue there's nothing in any other languages that are quite like it.
Okay. So the last question, and because when you mentioned the word metaprogramming, that's a book that I'm trying to get done for a year now, is Metaprogramming in .NET. Plug. So, when you mentioned the word metaprogramming, the one thing I know is if I introduce some of these concepts on projects that I go on or talk to other developers, they kind of get that deer in headlights look like, wow, this is really complicated and hard and really, at least with some of the stuff I've worked with, and granted in like languages like C# and VB, not so much F#, not in that world, but in those two, you don't really have a lot of those facilities. They're going to be coming now with Project Rosalind, the next compiler version of .NET. Well, maybe not the next version of .NET, but Project Rosalind has a lot of that in there. Would you say that's the same thing like in Clojure or languages like that, or because it's just a first-class citizen, it's just something that you can do, you just take advantage of that, and it's not as...
No, not at all. I'm totally with you, dude. It's, why I care about macros is not, I just said a bunch of geek crap, but the geek crap is like the implementation stuff. What's interesting to me is, can I make a language, or can I make a program using a language that's as small as possible? And I don't mean small in the sense of Perl, where it's like line noise.
Yeah.
And like, well, I wrote it a week ago, but I can't read what the hell
like
I wrote.
C obfuscated code contest or something.
Right,
like
exactly. It's short but still readable. Well, how do you do that? You have to be able to speak at the highest level of abstraction possible for any particular problem you're trying to solve, either at a macro or micro level. Basically, through any layer of the abstraction, you want to be able to speak at the highest level of abstraction as you can. And macros enable that because by having facilities that allow you to generate code that gets evaluated that gets generated at compile time to then be evaluated at runtime, you're able to create more powerful abstractions. That's the appeal to me. Now, bear with me because I'm going to answer your question.
Okay.
So it's this powerful facility, and that's what I want. Now, with any powerful facility, if you're not used to it, because you haven't written code in languages that have that, I very strongly believe in the notion that while language doesn't completely generate thought, I think that's sort of been discounted in the world of linguistics mostly. Mm-hmm. I do think it's certainly an influencing factor, and it defines constraints. And I do believe, at least in the world of computer programming, that people learn to not want what is available to them. I see that even in the realm of C#. I was just at a gig earlier this year where I just got to be sort of like Joe Coder, like one of the dudes in the trenches. And I found like all of this code where they were basically duplicating, it was sort of this service shell on top of like another service layer. Mm-hmm. Don't ask.
We've all been there.
I didn't make it, I was there. And they had all of these try-catch blocks that all sort of looked the same, except some variations were starting to peek in here and there in the catch blocks because somebody would go in and fix their particular problem. Right. Well, the obvious thing that's completely available to you right now in C# is, well, really what you want is a method that defines this try-catch, and I just want to be able to pass in the particular little lambdas. Yep. So I was able to take this much code and turn it into this much code, just with the functional abstractions. Yep. Now, the people there, they're not bad guys. In fact, some of them were actually fantastic developers. But they had learned to not use things that were available to them because they had never been available before. And that for sure is a problem. I think you see that in the C# world right now, that people aren't taking advantage of the functional abstractions that are there. Yeah. So if you then introduce the notion of syntactic abstractions, well, that's even a level higher or more abstract. Abstract.
Right. You just want to become a god.
It's a way of becoming the ultimate programmer. Eventually I won't program.
Oh, I'll just write one set of parentheses and just boom. And
things will happen. I almost work that way in IntelliJ and like Visual Studio. Just I don't know, I hit Control Space until code gets written. But I think that's why I wanted to actually, because I've done closure talks in the past, and I really wanted to do one where we just talked just about the macro facility, because I feel like I'm never able to sort of like give it the treatment that it deserves. To say, look, this abstraction exists.
Right.
It's powerful, but it's not that scary, really, if you sort of start to become familiar with it and understand what it's doing and when it's doing it in the life cycle of a program.
Right.
So that if you can start learning about how it works, then either you can start using it in languages where it's available, or you can start demanding it in languages that aren't.
Right. And I think you bring up a good point too, that generally in the .NET space, it's people that want to take their data from ADO and put it onto a grid. You know, I mean, there's a substantial amount of apps that are just load data, show data, and maybe change it, and munge it, and save it. You know, there's not a lot of prettiness or wonderfulness. It's not like it's not worth what these people use it for. But the developers just get into this, I need to just do this mode, you know.
But ironically, because it's the same in the Java space too, which is where I've spent most of my time as you know. But there's really similar worlds, right? It's like I'm building an internal web app for some huge corporation on a Java stack, or I'm doing a .NET stack. Basically, you're making the same mashed potatoes.
Yeah.
And one thing that comes up in Lisp, that people talk about in the Lisp community a lot, that with the power of macros, whereas in other languages you have this notion of like idioms and design patterns, that in the Lisp community, when you see something that another group of people call a design pattern, you say, oh, you're manually writing out macro expansions. I could write a macro and make that go away. So even though I think that there is this sort of feeling of like, well, that's an esoteric programming concept that doesn't really apply to me because I'm trying to do relatively simple things, I would argue completely the other way. It's like because you're doing a simple thing that is pretty repetitive, that actually the metaprogramming facilities can shine there, because you can take all this code that you write. I mean, think of how much time you've spent in your life writing code that's essentially exactly what you did at the previous gig. It's like, well, I'm writing a data access layer, and here's the services, and I'm doing this, and oh my gosh, for the 9,000th time, please, if only a meteor would come from outer space and strike me right now so I could not do this again.
Right, but I mean, if you can not just reuse what you did before, but reuse it so that it's less pain and it's obvious as to what. One example, I'll just throw this out here too. One example that I've done at clients is the classic pattern of I got to open a command or a connection, and I got to open a command, and I got to execute my reader, and then I got to read from it. And you got to do all this within a using statement. You got to do all this with parameters. And we basically did it where we turned it around and said, rather than that's all there, when you need to set up your command, you get a function. We give it a lambda expression or anonymous method actually, and that's what you'll get the command, and you just set it up. And then down below, that's the result set. That's the reader, and then you just get that. And all the rest of that gunk is hidden somewhere else, and you don't have to worry about it. And it becomes much cleaner. You know, all that stuff of, well, and then I need to log when the connection's open. Guess what? That happens over there.
And it's not purely geeky goodness. I mean, it translates directly into sort of cost and maintainability, because, I mean, like the stupid example that I gave before, well, if we were just beginning development on a rewrite project that hadn't even gone into production for the first time yet, and there were already these insipid bugs creeping in from, well, the way an exception was going to be handled with that service call was going to be different from the way it was going to be handled from that service call, and that was only going to expand over time.
Yeah. When
at a more abstract level, what you're really trying to say is handle an exception coming from an underlying service. And C# allows you to, unlike Java, well, I mean, you can do it in Java, but it's hugely painful because you have to use anonymous classes. They don't really have the notion of limit yet. And they're going to do it.
The syntax that they take was C#.
Well, thank God. I mean, it's because it's like just, if you're going to steal the good stuff.
And they even admitted it. They said, like, they tried to do this really funky, ugly syntax, and then I just saw recently they said, okay, we finally decided, and we're just going to copy C#. It was just hilarious. You know?
I think it was because interestingly, I think it was actually because there were too many Lispers in that community, and they were looking for something more like Lambda, and there weren't like ML people, whereas like the C# sort of came from F#, came from ML. It was like, oh, that's how we're going to stick Lambdas in, and it sort of just like looks prettier when you look at it. It just, I mean, in a way you could say, who cares? It's just syntactic sugar, but as I get older, I'm getting more and more into sort of the aesthetics of something, because I feel that, I do believe that, and it's true for hardware, and it's true for software, and it's true for all the things that we use, that beauty's more than just beauty, that when something's beautiful and aesthetically clean, it becomes easier and more pleasant to work with.
Well, and you also, it's just something, yeah, you're like, this is awesome. I saw a talk that Scott Hanselman did a week or a couple weeks ago, and he said, you know, he still gets the thrill of like 2 in the morning. He did something, he coded, all of a sudden, it just poof, it works and it's beautiful. He just wants to go like, you know, run down the hallway at 2 in the morning and go, look what I have created.
I am the smartest man alive.
You know, behold
to me,
and
puny humans.
And that's why we do what we do. So, thank you, Chris.
Thanks for having me.